Okay, this is just a simple electric field from a point problem. Pause and read the question. I hope you've done that. So we want to find the magnitude and direction of the electric field some distance away from a point charge. Our point charge is just held in space. Remember, the electric field is caused by charge. If you have charge in space, that permeates all of space and changes the very fabric of space. We call that change the electric field. Then, if you put another charge, a second charge, in that electric field, that second charge will feel a force from the field, and that force will be Q times E. F equals QE. So here we just want to calculate the magnitude of the electric field. That's K Q over R squared. This is just a fancy way of saying K, 1 over 4 pi epsilon naught. That's just approximately 9 times 10 to the ninth. Q, of course, is the charge of our particle, so we just plug everything in. Our distance was 25 centimeters. So we get an electric field strength of 720 newtons per coulomb. Remember, electric field, this coulombs all here gives us the magnitude. To find the direction, we just use electric field permeates outward, away from positive charges, and toward negative charges. So here, since this was a negative charge, the electric field will point down toward it, because remember in the question, we're directly above it. So the electric field will point down toward that negative charge. Remember, nano here means 10 to the negative ninth. Part B, we want to know what distance we have to go until the field drops off to only 12 newtons per coulomb. So the easy way, the way I would have done this problem, is just use Coulomb's law here, plug in a 12, plug in our Q, plug in our K, and solve for R. It's really not even a bad problem. This solution I'm using, because they have a nice pretty formula already typed up for me, did it using proportions. So the ratio of two fields should be the ratio of the distances squared, but these r's are flipped over, because remember, E goes like 1 over r squared. So I've got R2 on top, R1 on the bottom. So we could solve that for R2 and just plug in values we already have and get 1.94 meters. So remember, with electric field, from point charges, the field drops off like 1 over r squared. If you go twice the distance, you get 1/4 the electric field.